Hello Year 10. So what we're going to look at today is we're going to look at factorising quadratic expressions where what we're trying to factorise is in this form here. Okay. So the work I set you on Tuesday, I can see you've had a really good go at. You're pretty decent at those skills, but you haven't had anything written in this form where we've got a number in front of the x squared and there isn't a common factor we can take out. You may have seen something like 3x squared plus 6x, for example. So there is a number in front of the x squared there, but this would factorise into a single bracket because we've got a common factor there of 3x. So that one would factorise to 3x and then x plus 2. But what we're looking at are things like this where we haven't got a common factor amongst our terms. So it's going to have to be a double bracket factorisation. But the double bracket factorisation is made more difficult by the fact that we've got a number in front of the x squared. Right, so let's have a look at the method for how to best do this. Okay, so the first thing you're always going to do when you've got something like this is you're going to look at the value of a and the value of c. Now what I mean by that is the number in front of the x squared and the number by itself at the end. Okay, so I'm going to I'm just going to make it clear what I mean there. So I've got a and I've got c, my first number and my last number if you like. And what I'm going to do is I'm going to multiply those two numbers together. So I'm just going to do this at the side. I'm going to do 6 times 2, which is 12. Okay. Now what I need to do to start factorising this is I need two numbers, and the two numbers I need have to multiply to 12. This value I've just worked out, this number 12. Okay. And they need to sum, so they need to add up to the number which is our value of b. Okay, so a pair of numbers that multiply to 12 and add up to 7. Okay, so at this point here, what I recommend you do is start listing pairs of numbers that multiply to give me 12. So I'm going to have 1 and 12, 2 and 6, so on. But as soon as I want them to add up to 7, it's going to be 3 and 4. So I could just check that. 3 times 4 equals 12. 3 add 4 equals 7. This is what we want, isn't it? So you can, little smiley face there, we're happy. Okay, so the question is, what do we now do with this 3 and this 4? So what we use this 3 and 4 for is we split up our middle term, our x term. So what I'm going to do is I'm just going to move over here and write out again, just so I've got a little bit more space. Okay. What I do is this 3 and 4, as I split this middle 7x up into a 3x and a 4x. So I'm going to write that out as 6x squared plus 3x plus 4x plus 2. And the reason I've split it into 3x and 4x is because I decided 3 and 4 are my magic numbers, if you like. Okay. So all I've done is rewritten it, but in some ways it almost looks worse, doesn't it? But what we do is we now look at this as two separate expressions. We look at this expression here and we look at this expression here, and I factorise each of them separately. Okay, so looking at this first excuse me looking at this first expression here, what I need to do factorise this is look for common factors. There is a common factor there, isn't there, of 3x. Okay, so I'm going to take that out as a common factor. So I'm going to have 3x bracket, and it's going to be 2x plus 1. Okay, so all I've done is factorise what I've got here. Now if I look at my second two terms, again I'm going to factorise. I've got a common factor here of 2. So I'm going to take out a factor of a positive 2, and then within the brackets I'm going to need 2x and plus 1. Again, it almost looks more complicated, but the really important thing here is that we should have the same in both of these brackets, and we have. Okay, we've got a 2x plus 1 and another 2x plus 1. So over here I've got 3x lots of 2x plus 1, and here I've got 2 lots of 2x plus 1. So altogether, what I have is 3x plus 2 lots in total of 2x plus 1. So this now is my final factorised form. Of course, what we could do now if we wanted is we could multiply this out using a grid method or a FOIL method to check that when we multiply out this set of double brackets we get back to this. Okay, let's have a look at a second example then. So our second example is we want to factorise 2x squared plus 5x minus 12. Okay, so the first thing I'm going to do is I'm going to identify a and c. Okay, the coefficient, the number in front of the x squared, and c is the value at the end. Common error here would be people just to see 12. It's not a 12. It's a minus 12, isn't it? Okay, so what we're going to do is we're going to multiply a and c together. So 2 multiplied by minus 12, which is minus 24. Okay, so I'm looking for two numbers now that multiply to minus 24, and we want them to sum to positive 5. So they're going to sum to 5. So again, I'm going to start listing pairs of numbers now that multiply to give me minus 24. So what I could do is I could try minus 8 and 3. So minus 8 times 3 is minus 24, yeehaw. Minus 8 plus 3, however, gives me minus 5. That combination of minus 8 and 3 hasn't worked. That's fine. List those combinations that don't work and just cross them off. You're just getting closer to the answer by ruling out ones that haven't worked. Let's try another pair of values. Looked like we were pretty close there. We just got a negative 5 instead of a positive 5. So this time I'm going to try 8 times minus 3, which does give me minus 24. And then if I do 8 add minus 3, that does give me 5. So they multiply to minus 24, and they add to 5. Yippee. Okay, so now this 8 and minus 3 is what we're going to split this 5x term up into. Okay, so again, I'm just going to write it over here just so I've got a little bit more space to work with. I'm going to split it up. So I'm going to split my 5x up into a minus 3x and then positive 8x. So minus 3x plus 8x minus 12. Okay, and this is equivalent to the line above. It's just I've written 5 as minus 3 plus 8. So now, same as last time, I'm going to look at the first two terms and the final two terms separately and factorise them. So factorising this, the only common factor I've got here is a common factor of x. And then we'll have 2x minus 3 inside our single bracket. And then here, our common factor is a common factor of 4, a positive 4. And then I'm going to, within my bracket, I'm going to have 2x minus 3. So again, I've got the same thing here in both my brackets, which is giving me a strong indication that I'm on the right tracks. So I've got x lots of 2x minus 3 here, I've got 4 lots of 2x minus 3 here, so altogether I've got x plus 4 lots of 2x minus 3, and this is my factorised form. If I wanted to, I could multiply out the brackets here and see if it works. Now, something some of you may be thinking at this point is, well, what if we got to here and then I decided to put the 8x there and the minus 3x there? Why do we know to put them in that order? Well, let's see what happens if we have them the other way around. So 2x squared, and instead of putting the minus 3x, let's put the positive 8x there, the minus 3x there, minus 12. So I could have just as easily put that as my second line of working out, but it's different to this, isn't it? So let's see what happens when we try and factorise. So here, if we're looking for a common factor here, I've got a common factor of 2x. So inside my single bracket, I'm going to have x plus 4. And then if we try and factorise this, it might be tempting to just take out a factor of 3. So if we take out a factor of 3, I'm going to end up with minus x minus 4 in the bracket. Now at this point, we've got a problem, haven't we? We haven't got the same thing in both brackets. However, what we could go back and say, well, another way of factorising this is rather than taking a factor of 3 out, what if we took out a factor of minus 3? If we had minus 3 on the outside, I'd need a positive x and plus 4, and then I have got the same in both brackets. Okay, so if you haven't got the same in both brackets, just check your single bracket factorisation. Okay. So now if we look what we've got the same in both brackets and x plus 4. I've got 2x lots of x plus 4. I've got minus 3 lots of x plus 4. So altogether I've got 2x minus 3 lots of x plus 4. So we've actually got the same answer written twice. So don't worry about which way to write these two things, because even if you have them the other way around, you will end up with the same final answer. Okay, so there's an overview of a method you can use to factorise something that's in this trickier form, and this is as difficult as the factorisation gets at GCSE maths. Now, part of the work I've asked you to do today, I've asked you to have a go at an activity that looks something like this. So just a quick overview of how it works. So each expression you're given, you'll need to factorise. So this one here, we've got x squared minus 9. You should all be screaming dots at this point. It's a difference of two squares. So that would factorise as x plus 3, x minus 3. And then this one here was our first example for today. So this one is 3x plus 2 and 2x plus 1 when we factorised it. So if we just look at what letters we've got here, so x plus 3 is u, x minus 3 is L. Here, 3x plus 2 is B, and 2x plus 1 is E. So we're looking for a colour. Those are the letters we've got. It's going to be blue. Okay. So just a slightly different activity for you to work on today, just to practice those skills of factorisation that I've just been going over. Okay. So at this point, I recommend you stop the video and have a go at that activity. Don't worry if you're struggling with the anagrams. Once you've factorised the expressions, do feel free to cheat a little bit and go onto an anagram solver or something like that on the internet. Don't worry about the fact you can't figure out the correct word. The thing we want to be practicing is this skill here. This is the important thing. So stop the video and have a go at that. Okay, I'm just going to carry on now onto the work for Friday, so the work for the 24th. So what we're looking at on Friday is we're looking at solving quadratic equations. Now we have done this previously, and when we've looked to solve quadratic equations, we've factorised, we've split, and then we've solved. Okay, so this is one similar to ones we've seen previously. We did this earlier on in the year. So we haven't got a number in front of the x squared. We're just looking to factorise this. It will be a double bracket because there isn't a common factor. I want a pair of numbers that multiply to 12 and add to minus 7. So when I factorise this, it's going to be x minus 3 and x minus 4. Okay. So when we now go to, we factorised it. Step 2 is to split it up. So when we split it up, we do x minus 3 equals 0, or x minus 4 equals 0. I've got two little equations to solve. So if I solve this one by adding 3 to both sides, I'm going to get x equals 3. And if I add 4 to both sides of this one, I'm going to get x equals 4. Okay, so that's something we've seen previously. This one here, a bit more difficult. This will look familiar from yesterday's lesson, from Thursday's lesson. It was our first example. It's exactly the same process. So we start off by splitting it up. So when we factorised this previously, we got 3x plus 2 and 2x plus 1. Now, in order for you to get to this step, you are going to have a number of lines of working out doing what we did in the previous lesson, okay? So you can expect to see all of this as part of your working out before we get to this stage here, okay? It's not as if I'm expecting you just to be able to pull this out of thin air, okay? It's just, I'm trying to keep this video relatively short so you don't get too bored. So, we factorised, we now split it up. So we've got 3x plus 2 equals 0 and 2x plus 1 equals 0. So now we've got two little equations to solve, so I'm going to solve this one by subtracting 2 from both sides. So I get 3x equals minus 2. And then I'm going to divide both sides by 3. And of course, we will leave our answer as a fraction because fractions are your friends. Okay, so there's one solution. X is minus 2/3. We've now got our other little equation to solve, so we get 2x equals minus 1 by subtracting 1 from both sides. Then divide both sides by 2 to get x equals minus 1/2. Again, you could write it as a decimal, but why would you want to when you can leave it as a lovely fraction? So what I recommend you do now is have a look at these two questions here. Pause the video, see if you can factorise those accurately, and then split and solve. See if you can get the correct answers for these. And in a second, I will just write up the answers so you can check how you've done. So just pause the video now and have a go at these 2 questions. Okay, so hopefully you've not cheated and just let the video continue to roll. Hopefully you've stopped and had a go at this. If you haven't, shame on you. So final answer you should have for this one, x equals 1/5 and x equals 4 should be your final answers. And then for this one here, your final answer should be x is 7/2. Of course, you could write that as 3.5 if you're an animal, but why would you want to turn it from a lovely fraction into a horrible decimal? And the other solution you should have is -5. If you haven't got these answers, just go back, double check your work and see if you can spot where you've gone wrong. Maybe go back in the video and go over the factorisation and this idea of splitting and solving. If it's still not making sense, obviously you ask me for some help over the VLE and I'll do what I can. Okay. One last little thing, and then I will leave you to enjoy the work I've set you, is what happens for one like this. Okay. So in this case, it looks different. It's not equal to 0, and that's the key. All we're going to do is we're going to make it so it is equal to 0. Okay, so I'm going to take this equation. First thing I'm going to do is I'm going to subtract 3x from both sides. So that'll give me 2x squared minus 3x equals -1. I'm now going to add 1 to both sides to get 2x squared minus 3x plus 1 equals 0. And now it looks very similar to our previous 2 examples. So we're going to factorise, split, and then solve. Okay, so when we factorise this, we are going to get 2x minus 1 and x minus 1. So again, that's just using that extended method that we looked at previously to get there. It's not that I'm expecting you to do that. I've already worked it out and got it written on a piece of paper over there, so I've just glanced over. So we factorised it. Now we're going to split it. So we're going to have 2x minus 1 equals 0, or x minus 1 equals 0. 2 little equations to solve. So this one I'm going to add 1 to both sides, then divide by 2. And then this one here, I just need to add 1 to both sides. So my 2 solutions will be x equals 1, x equals 1/2. So with one like this, the key is make it equal to 0 before you factorise, split and solve. Okay, so you've got a series of questions to have a go at now. What I'd like you to do is have a go on a piece of paper in your exercise book, whatever. Take a photo of the work you've done and send it through to me, and I will check what you've done, because I'm really keen to see how you're getting on, because I know lots of you are working really hard, and it would be nice for me to have a look at the fantastic work you're producing.